pick up something solid, right now your phone, a cup, the edge of a table, and notice how absolute it feels. It has a boundary. It resists you. It pushes back with a certainty that seems almost moral, as if the universe itself has drawn a line and said, "You may not pass." We build our whole intuition on that feeling. We grow up thinking solidity is what matter is. That objects are made of continuous stuff packed together with no gaps, and that when two things touch, they simply meet, surface to surface, like two blocks of wood pressed together. But if you follow the physics down even a little bit, that story falls apart, and what replaces it is both more beautiful and more unsettling. Nothing is actually solid in the way your senses insist. Because solid is not a fundamental ingredient of nature. It has an emergent behavior, a macroscopic effect produced by electric forces and quantum rules acting on mostly empty space. Start with the most basic fact you rarely force to picture. Atoms do not fill their own volume with material, the way a rock fills a bucket. An atom is mostly open space, with a tiny dense nucleus at the center, and electrons described not as little planets, but as a spread-out quantum state, a cloud of probability and charge density that occupies a region vastly larger than the nucleus. If you scale an atom up to the size of a stadium, the nucleus is a speck near the center more, like a fly than a baseball, and the electrons are not neat orbiting beads, but a smeared-out distribution, an invisible structure that tells you where the electron can be detected. The point isn't that nothing is there. The point is that the there is not a hard surface. It's a field-like quantum mechanical arrangement. So when you press your palm against a tabletop and you feel hardness, what exactly is interacting with what? At the level of atoms, you are not pushing a continuous substance into another continuous substance. You are bringing the electron structure of your skin close to the electron structure of the table. And the closer those electron distributions are forced together, the more violently the energy of the system rises. Part of that rise is straightforward electromagnetism. Electrons are negatively charged, and charge distributions resist being piled into the same region, because like charges repel, and because the electric potential energy increases sharply as you try to compress electron clouds. But the deeper part, the part that really explains why matter has rigidity instead of collapsing into a dense smear, is quantum mechanical. And it has a name that sounds like a bureaucratic rule, but functions like a law of existence, the Pauli exclusion principle. Electrons are fermions, and fermions cannot all occupy the same quantum state. When you bring atoms close, you are not merely bringing charges near charges. You are trying to force two sets of electrons into overlapping states that are not allowed to be simultaneously occupied in the same way. And the universe pays for that attempt with an enormous increase in energy. That increase shows up macroscopically as a force, what you feel as pressure and stiffness. In other words, solidity is not a property of stuff. It is the price you pay for trying to compress quantum matter into configurations that the rules forbid. This is why the everyday picture of atoms as tiny billiard balls is misleading. Billiard balls are hard because they are made of smaller hard things packed together, but atoms aren't hard marbles. Their edges are not walls. They are regions where electron probability and electron density become significant. And what you call a boundary is the region where the energy penalty for further overlap becomes enormous. If you want a clean, almost ruthless way to see it, imagine a graph of potential energy versus separation between atoms. Far apart, the atoms barely notice each other. Bring them closer, attractive forces from bonding pull them in. Closer still, the curve turns sharply upward and becomes a near vertical wall, not because there is a literal surface, but because the combination of Coulomb, repulsion, and Pauli exclusion makes it energetically catastrophic to push further. Macroscopic sensation of a solid surface is your nervous system registering that steep wall in the energy landscape. And that same wall explains why you don't fall through the floor, not because the floor is filled with impenetrable substance, But because the energy required to force your atoms into the floor, as atomic structure, is astronomically large compared to the energies you have available. You are stopped not by a barrier made of matter, but by a barrier made of physics, by the way electrons and fields respond when you attempt to occupy the same region. And once you see it that way, you start to realize that even the phrase empty space inside atoms is tricky, because empty is a word from classical geometry, and the microscopic world is not classical geometry. Those regions are filled with fields and quantum states, and the things that matter most are not whether there is stuff sitting there like clay, but what the allowed states are, and how energy changes when you try to rearrange them. This is why solids can be incredibly strong, yet still be compressible if you apply enough pressure. Because you are not crushing a rigid continuum, you are forcing matter up that energy wall and into new arrangements, changing the electron structure, and sometimes even the nuclei's relative positions. Push hard enough, and solid turns into something else, liquid, plasma, degenerate matter, because solidity is a phase, a regime of stability, not a metaphysical category. You can see the same truth in something as ordinary as sound. If solids were truly rigid, a push on one end would be felt instantly on the other end. But nothing in nature is infinitely rigid. Information travels through a solid at the speed of sound in that material, and that speed is finite because the atoms communicate forces by tugging and pushing through electromagnetic bonds, like masses connected by springs. That springiness is exactly what a solid is. Atoms locked into an arrangement, vibrating around equilibrium positions, exchanging energy through chemical bonds and electron interactions. Even at room temperature, the atoms in your table are not sitting still like stones in mortar. They are vibrating constantly because thermal energy excites collective modes called phonons. Cool the solid down and those vibrations shrink. But they do not vanish completely. Quantum mechanics leaves a residue called zero-point motion, meaning the atoms never become perfectly still. So the solid that feels immovable is on the inside, a dynamic lattice of vibrating atoms, sustained by forces and constraints, not a frozen block of continuous substance. And if you want the most brutally honest statement of what solid means, it is this: a solid is a system where the atoms are bound in a stable arrangement, and where small deformations cost energy. So the system produces restoring forces when you try to distort it. That's it. No magic, no impenetrable matter. Just an energy landscape and the rules that shape it. The reason a diamond is hard is not that it is more solid than other solids. It is that its carbon atoms are bonded in an exceptionally stiff network, so the energy wall against deformation is steep. The reason rubber feels soft is not that it is less real. It is that its polymer chains can rearrange and uncoil with relatively low energy cost. So your push is absorbed by internal reconfiguration rather than by a sharp rise in repulsive energy. The reason metal can be bent is that metallic bonds allow layers of atoms to slip under stress while maintaining cohesion, whereas brittle ceramics fracture because their bonding and defect structure don't accommodate that slip. All of these are different versions of the same story. Solidity is a macroscopic behavior that emerges from microscopic interactions, mostly electromagnetic, shaped by quantum rules, and it comes in degrees because different structures have different energy costs for deformation. And then there is the thought that usually makes people feel dizzy. If atoms are mostly open space, why can't we thread ourselves through that emptiness, slipping between nuclei the way smoke slips through branches? The answer is that the emptiness is not an empty highway, because you aren't trying to steer small hard beads through gaps. You are a huge collective of electron states and nuclei, and as soon as you attempt to overlap with another huge collective, the electron structure resists with a force that escalates insanely fast. The gaps inside matter are not passages you can navigate through. They are regions already occupied by electron density and governed by the requirement that the total wave function of electrons remain antisymmetric. You don't pass through, because to pass through would require reconfiguring electron states on a massive scale. Climbing an energy mountain so steep that your muscles, your chemical energy, your entire biological engine is laughably insufficient. That's why solidity is real in practice, even if it is not fundamental in the naive sense. The barrier is not an illusion. It's an energy barrier enforced by nature's rules. You can, however, see hints. That solidity is conditional. Extremely energetic particles from space do pass through you. Cosmic ray muons, created high in the atmosphere, streak through your body by the thousands every minute, barely interacting, because at those energies and with those interaction probabilities, solidity is not the dominant story. The muon docenti feel your table. The way your hand does, because its interaction with your electrons is rare and weak enough that it can traverse large amounts of matter without being stopped. That single fact should rearrange your intuition. Solidity is not, this thing is filled with substance. It is, this collection of matter strongly interacts with that collection of matter in a way that resists overlap. Change the particle, change the interaction strength, change the story. Neutrinos pass through the Earth as if it weren't there because they interact so weakly. Your hand cannot pass through a tabletop because the electromagnetic interaction between your electrons and the table, psi electrons, is overwhelmingly strong at angstrom scale separations. And the Pauli principle makes the energy cost explode as you try to compress states. The same reality produces impenetrable walls for you and transparent earth for a neutrino, without contradiction, because solid is not a universal label. It's a relationship between objects and the forces available to them. And once you accept that, you can see the world with a different kind of precision. The chair is not a chunk of solidness occupying space. It's a structured arrangement of atoms whose electron bonds create a stable lattice, vibrating, exchanging energy, and producing large restoring forces when you disturb it. The surface is not a boundary where matter ends and emptiness begins. It is the region where your electron density meets its electron density, and the energy landscape rises like a cliff. The feeling in your fingertips is not contact in the classical sense. It's your nervous system translating electromagnetic forces and quantum constraints into pressure, texture, and resistance. And the weirdness doesn't cheapen anything, it deepens it. The fact that solidity is an emergent consequence of fields in quantum statistics means the everyday world is not made of simple chunks of stuff. It's made of rules so consistent and so relentless that they create the illusion of stuff. You don't live in a universe of solid objects. You live in a universe of interactions so strong and so orderly that, at your scale, they behave like solidity. That is why you can hold a childless hand and feel warmth and firmness and presence, even though at the microscopic level the firmness is electron clouds refusing overlap and quantum states refusing duplication. The reality underneath is not less real. It's more real because it tells you what is actually doing the work. Nothing is actually solid the way your ancestors had to imagine it to survive. Solidity is not a substance. It's a consequence. It is the macroscopic signature of electromagnetism and quantum mechanics doing what they always do everywhere in the universe, quietly holding matter apart, holding structures together, and turning mostly empty space into a world you can sit on, build with, and trust with your life.